Okay, so we've got a question here. Suppose the demand function for a firm's product is given by, this is our demand function here, where Px is the commodity of the price, Py is the price of the related commodity, M is per capita disposable income, and A is advertising expenditure, thousands of dollars. So we've been given Px equals 10, Py equals 4, M equals 20,000, A equals 250. Watch. All right. So question one, determine the own price elasticity of demand and state whether the demand is elastic, inelastic, or unitary elastic. So colleagues, we need to remember this. Number one, when we talk about price elasticity of demand, it means how quantity demanded responds to changes in price. Okay? How quantity demanded responds to changes in price. So if quantity demanded is very sensitive to price changes, meaning if you increase price by 1%, you find quantity demanded drops by 50%, then you know that the demand for the good is elastic. Okay, when you say elastic demand, it means quantity demanded is very sensitive. Okay, it's sensitive to changes in price. A small price change, a big change in quantity demanded. Are we okay with that, Mr. Manas and Madam Julie? Was these are not going to miss in the exam? They are not going to miss these elasticities. Okay. When we say demand is inelastic, it means it is not sensitive to changes in price. Okay? Meaning you can increase price by 50%. You find quantity demanded just goes down by, let's say, 20%, by a small amount. Okay. So that's why we say demand is inelastic. It's not sensitive to changes in price. Okay. But it doesn't respond greatly to changes in price. So we say demand is inelastic. Are we okay with inelastic demand? Definition of inelastic demand. Unit elastic, it means if quantity demanded changes at the same percentage as price, when we say unit elastic, okay? Percent change in quantity demanded will be equal to the percent change in price. Meaning, if you increase price by 5%, quantity demanded will drop by 5%. If you increase price by 30%, quantity demanded will drop by 30%. That is what we call unit elasticity. Okay. So, mhm. Is there a question? Okay. So the first thing that we need to do with this type of question here, okay, is first we need to calculate our quantity demanded with these values given. Okay. That will be the first thing you need to do. Calculate quantity demanded with the values you are given. Would you mute your mic, sir? Getting feedback. Yes. So let's first find our quantity demanded. Okay. If we substitute the values in, let's see, let me put it on top there. If we substitute the values in, okay, so QD equals 3 minus half, substitute PX with 10 minus 2.5, PY, substitute PY with 4, 2.5 py4 plus m is 20,000 plus 2a. A is 250. A is 250. Okay, so we get our demand. So 3 minus half of 10 is 5. 3 minus 5 minus 2.5 times 4, that is 10, plus 20,000 plus 500. Okay, so we're going to say 3 minus 5 minus 10 plus 20,000 plus 500. We get 20,488 units. Okay, 20,488 units. Okay, that's the first thing you do with these questions. Okay, first find the quantity demanded. Okay, you will see the reason why. Okay, any questions before I move to the next part? Okay, so now we have to determine the on price elasticity of demand. So on price elasticity of demand, this is the formula, is the partial derivative of the demand function q dx. Here we're deriving this function with respect to px. All right, and then we are multiplying this by px divided by the quantity demanded q dx. This is the formula, colleagues. Okay, we are going to derive this demand function here, which we've been given in the question. Okay, we're going to derive this equation here with respect to px, and then we multiply that by the price of good x over the quantity demanded, this 20,488. Okay, colleagues? So this is how we derive. When we say we're deriving, partially deriving with respect to px, in simple words, it means in the demand function, if you do not see a px with a number, that number disappears. Okay? This statement here, partial derivative of q dx over partial derivative of, yes, over px, this, it's telling us that in this demand function here, if a number doesn't have a px, it means that number disappears. Okay? So this 3 disappears. This negative 2.5 py disappears. This m disappears. This 2a disappears. So it means what we are deriving is only this negative half px. Okay? That's all that we are deriving, this negative half px. Okay? So to derive this negative half px, just say negative half px. This px is to the power 1. Okay, so with deriving, remember, multiply the exponent with the coefficient. 1 times negative half, that will give you negative half. All right. Then subtract a 1 from this same exponent here. 1 minus 1, that is 0. Okay, 1 minus 1, that is 0. So you remain with a px, remain with a negative half px to the power 0. And remember, anything to the power 0 equals 1. Okay, so this px to the power 0 is the same as 1. Okay, so we've derived, we get negative half. Any questions? All right, so we're going to say negative half multiplied by px. We've been told it's 10, so you say 10 over q dx, this 20,488. So you say over 20,488. Okay, so we're going to say negative 1 times 10, that is negative 10. 2 times 20,488, you get 40,976. Okay, then you're going to say 10 divided by 40,976. You get negative 0.0002. Negative 0.0002. Okay, so we need to interpret this. Now, listen carefully here, colleagues. Due to the law of demand, because price and the quantity demanded have got an inverse relationship, meaning one will be going down, one will be increasing, one will be decreasing. So whenever you're tabulating price elasticities of demand, you're always going to be getting negative values all the time, negative values. So once you get that negative value, get the absolute value, meaning when we say get the absolute value, it means just ignore the negative sign. Okay, so our absolute value is 0.0002. Okay, absolute value just means ignore the negative sign, just read the number as it is. Now, do you know the reason why we're getting the absolute value? The reason why we're always getting the absolute value is because negative is less than 1. Okay, any negative number is less than 1. Okay, so any number that is less than 1, it means your price elasticity of demand is inelastic. Okay, if your value of your price elasticity of demand is less than 1, it means the value of your the demand for your good is inelastic. So if you're always just getting negative values, then it will mean every time you just be interpreting that demand is inelastic, when in other cases it won't be the case. Okay, because negative is always less than 1. Okay, so if you do all your calculations every time, you always get a negative value, and you always be translating at that's inelastic, which won't always be the case. So that's why we get the absolute value, so that we can see is it elastic or inelastic, because negative values are always alluding to inelastic demand. Okay, is that okay, Madam Juliet, Mr. Manasseh? Okay, so as I said, if your price elasticity of demand, PED, is less than 1. Colleagues, just hold on. Yes, when price elasticity of demand is less than 1, it means that demand is inelastic. Like in this case here. Okay, this 0.002 is less than 1. So we say demand for this good is inelastic. Okay, meaning if the price changes by a great amount, no, yeah, if the price changes by a huge amount, quantity demanded won't change by a great amount. Okay, it will drop by a less amount. Okay, yes. So any questions, colleagues? So the demand for this good is inelastic because it's less than 1. If it's greater than 1, it's elastic. Okay. If your PED is greater than 1, remember, then demand is elastic. Remember this demand is elastic. If PED equals 1, then that's when it's unit elastic, where quantity demanded changes by the same amount as price. So remember this, colleagues, because as I said, if you encounter this question, you need to interpret. All right. Okay. Yeah. So demand for this good is inelastic. It's not sensitive to changes in price. Okay. Yes. Okay. Any questions before we go to part 2? Okay, now we go to cross price elasticity of demand. This one is the one that determines substitutes or complements. Okay, substitutes or complements. You remember in our previous question, if your cross price elasticity of demand is positive, okay, this is the thing. Cross price elasticity of demand is written as XED. If cross price elasticity of demand is positive, you're dealing with substitute goods. Okay, if you remember in our previous question, we saw due to that positive sign, that's why we said our goods were substitutes. Okay. Another way to determine if your goods are substitutes or complementary, you can use cross price elasticity of demand. Okay. Cross price elasticity of demand, what it just means, how the quantity demanded of one good responds to changes in prices of another good. Okay. How the quantity demanded of one good responds to changes in prices of another good. Okay. So if your cross price elasticity of demand, XED, is negative, then you're dealing with complementary goods. All right. If your cross price elasticity is negative, you're dealing with complementary goods. Okay. So the formula for cross price elasticity of demand, okay, it is just the partial derivative of the demand function QDX we're deriving it with respect to py. Okay. Here, remember there was px. Now here we're replacing that px with py multiplied by the price of good y divided by the quantity demanded of good x. Okay. That 20,488 I told you, which we needed to calculate at first, as you've seen, it's in all formulae. Okay. So let us derive first. Again, we come to our demand function here. Let me highlight it in yellow. This is our demand function here. We look at it. We are now deriving it with respect to py. Okay, have you seen? There's a py under here. So it means if a number doesn't have a py attached to it, it goes. This 3 goes. This negative half px goes. This m goes. This 2a goes. Okay, because they do not have a py. So now we just need to derive negative 2.5 py. So this py is to the power 1. When deriving, you just multiply the exponent by the coefficient. 1 times negative 2.5, that is negative 2.5. You subtract a 1 from the exponent. 1 minus 1, that is 0. So get negative 2.5 py to the power 0. Anything to the power 0 is the same as 1, so you don't even need to put py to the power 0, because that equals to 1. Okay, colleagues? So we've derived our value is negative 2.5. Excuse me. Multiplied by the price of good y. Py we said was 4 kwacha over 20,488. Okay. So we're going to say negative 2.5 times 4, that's negative 10. So again, we get negative 10 over 20,488. Okay, so negative 10 divided by 20,488, we get negative 0.00048 or 49. Okay. So since we've got this negative sign here, this negative here, this negative 0 point thing, so we know that our goods are complementary goods. Okay. Because of this negative cross price elasticity of demand, our cross price elasticity of demand is negative. Okay. So uh, what was the question asking? Just ask us, determine the cross price elasticity of demand. Okay, it's the negative 0.0049. And then they're asking us, state whether the two goods are substitutes or complements. So they are complements because the XED is negative. Okay. They are complementary goods because the cross price elasticity of demand is negative. Okay, colleagues? Okay. If the cross price elasticity of demand was positive, then we're going to say that the goods are, how can I say, they are substitute goods. Okay. So we go to the next part. Determine the income elasticity of demand and state whether the good X is a normal or inferior good. So income elasticity of demand, how quantity demanded of a good responds to changes in income. Okay. How quantity demanded of a good responds to changes in income. This is the one which now determines whether a good is a normal good or an inferior good. Okay. So if your income elasticity of demand is positive, you have a normal good. If your income elasticity of demand is negative, okay, you have an inferior good. Okay. You have an inferior good. So here the formula, all right, we're going to partially derive the demand function with respect to m, meaning if the number doesn't have an m attached to it, it disappears over m times q dx. All right. Oh, let me just connect my laptop also to the charger. So just hold on. Okay. So we come back to our demand function. We're deriving it with respect to m, meaning if a number doesn't have an m, it disappears. If a number doesn't have an m, it disappears. So this 3 disappears, negative half px disappears, negative 2.5y disappears, 2a disappears. Okay, so now we're just deriving m to the power 1. Remember, multiply exponent times coefficient, 1 times 1, that is 1. Subtract a 1 from the exponent, so you have 1m to the power 0. When you have any variable to the power 0, you ignore it. Okay? So when we derive m, we just get 1. So say 1 multiplied by m in this question is 20,000. So you're going to say 20,000 over 20,488. All right. So 20,000 divided by 20,488, we get 0.976. Okay, we've got a positive. Okay, this is 0.976. So this is a positive value, which is telling us this is a normal good. Okay, so since the income elasticity of demand is positive, we're dealing with a normal good. Okay, normal good. I'll just put it here as ng. It's a normal good. Yes. Any questions? 0. Let me put this properly. 9. So this is 0.976.